So controlVoltage is an Arduino library for working with and generating control voltages just on your microcontroller and then using those to control Eurorack synthesizers or modular synthesizers of different kinds, or I suppose other areas where control voltages would be useful. So in this video, I just want to give a quick example of how to go through a basic control voltage Arduino sketch. Here I have an ESP32, which is the microcontroller I've been using to develop on. Heavily recommend using 32-bit ARM-based microcontrollers, just for so much better than using the 8-bit at Mega Chips. I'm using the built-in DACs on the ESP32. It has two built-in DACs, and I just kind of rigged this up with alligator clips. There's a 1/8" jack there, another one over here, and I'm sending those into a make noise no coast just to give a quick demonstration of how this works. So it's very simple to sort of set up and work with. In the code side, everything is configured to use the Arduino serial plotter to monitor. So if we go to our serial plotter, we can take a look at our signals. And in this patch, I'm generating two signals. One is a trigger signal, which is the red spikes, and the other is a control voltage, which has slew limiting on it to kind of create ramps to transition between values. So to generate this patch, all I did was include the control voltage library, instantiate two objects, one for each signal that I want to generate. I set up the DAC pins for my ESP32. If you're using a different DAC, you'll have to do that differently. And then I developed the library to be 12-bit as sort of by the default. So because the ESP32 DACs are only 8-bit, I had to set the bit depth here to make sure that the output range is correct. And you'll notice in the serial plotter that 255 is the maximum value, which is correct for an 8-bit system. So you can change the bit depth to suit whatever the bit depth of your current DAC is. In the main loop, doing three things. The first is calling a loop for each signal object, and this loop is where the new sample is being generated. So you definitely need that for the control voltage objects. And then we have a control signal loop and a signal rate loop. So we're working with control voltage here, so we don't have to be working at audio rates, but we do want to be working relatively quickly. So I'm using a sampling rate of, and actually I should update this, a sampling rate of 1,000 hertz, or 1 kilohertz. So that's not really audio rate, but it's fast enough to do control voltage. It's actually fast enough to do audio stuff as well if you're okay with kind of lo-fi audio. And then in the control loop, you can sort of set it to whatever would make sense. I'm doing this kind of slow. Every 400 milliseconds I go through, I generate a trigger on channel 2 just by calling channel2.trigger. And then I set a CV on channel 1. I'm using the ability of CV to have a ramp time. So we go to the new value over 200 milliseconds in this case. And then every time we go through this loop, we increment the CV for channel 1. So channel 2 is the trigger, and that's the red line. Channel 1 is the CV, and that's the blue line. And you can see the slew limiting as the signal sort of ramps up to the new value every time it gets called. In the signal loop, we have to get the values from both of these signals, and so get is the method to do that. This is really a mandatory thing. You have to call get because get also tells the object that we need to generate a new sample the next time we go through the loop. So this loop and this get are both they work together, and you have to have them both in your code. So I'm getting those, and then I'm writing them to my DAC, just using the onboard ESP32 DAC write function. And then this is formatted for getting the control voltage to display nicely in the serial plotter. And so over here, if I turn up the volume, here is our trigger signal, and here is our CV signal. And you can hear that CV a little bit better as I do that. So very simple, works really well, super easy to configure and generate Eurorack signals. I'll make some more videos covering the other functionality of the library.